Number 1, find the value of the expression where I is the imaginary unit. So we want to simplify x plus I squared minus x minus I squared. Well, when I square something, when I square a binomial like this, we should probably use a table to help us. I get x times x is x squared, I times x is xi, x times I is xi, and I times I is I squared. So that first quantity is x squared plus 2xi plus I squared. We'll deal with that I squared in a minute. That second quantity, I also need to use a table, or use the identity for squaring a binomial, but you get x squared minus xi minus xi, negative I times negative I is positive I squared. So that's x squared minus 2xi plus I squared. Well, this is really x squared plus 2x. I squared, the most important relationship you need to know is I squared is negative 1. So x squared plus 2x minus 1 minus this quantity, x squared minus 2xi. That's minus plus 2i. xi over here, I forgot the I. Again, I squared is negative 1. Distribute that negative through. You get x squared plus 2xi minus 1 minus x squared plus 2xi plus 1. X squared and negative x squared, negative 1 and 1, those are additive inverses, so those add to 0, and I'm left with 4xi as my final answer. So that expression is really 4xi. Number 2, express 1 plus I squared in a plus bi form. So again, we need to square 1 plus I. Well, 1 plus I squared is 1i squared. I squared is really negative 1, so 1 plus 2i plus I squared, which is minus 1. So that quantity, 1 plus I squared, is really just 2i. And part 3 says, use your previous answers to find 1 plus I to the 4th and 1 plus I to the 8th. Well, 1 plus I to the 4th, that's really 1 plus I squared times 1 plus I squared. So that's really 2i times 2i. 2i times 2i is 4i squared. That number is better known as negative 4. And then to find 1 plus I to the 8th, I'm going to use that same idea. That's 1 plus I to the 4th times 1 plus I to the 4th, or 1 plus I to the 4th squared. Well, that's negative 4 times negative 4. That's 16. So, again, just some more practice with working with complex numbers and squaring them. This would be crazy to actually do out by hand, but we already using your previous result makes the question a lot simpler. Find the product of negative 3 plus 2i and its conjugate. Well, to find the product of something and its conjugate, we need to know what a conjugate is. The conjugate of negative 3 plus 2i is negative 3 minus 2i. A conjugate, you just need to change the middle sign. So when you find this product, you get negative 3, I'm going to use the distributive property here. I get 9 plus 6i minus 6i minus 4i squared. Those add to 0. 9 minus 4i squared is really plus 4, because I squared is negative 1, so negative 4 times negative 1 is positive 4. I get an answer of 13. Verify that 2 minus I is a solution to that equation. Now there's a couple ways to do this. You could actually solve this equation by using the quadratic formula, or you could substitute. You could take 2 minus I and plug it in. So I have 2 minus I squared minus 4 times 2 minus I plus 5. Hopefully we get 0. 2 minus I squared is 4 minus 4i plus I squared, distributing a negative 4 here, minus 8 plus 4i plus 5. Hopefully this quantity equals 0. 4 minus 4i minus 1 minus 8 plus 4i plus 5. Well, negative 4i and 4i are additive inverses, so those add to 0. 4 plus 5 is 9 minus 9, that equals 0. So it indeed a solution. 2 minus I is a solution, because when I plugged it in, I got 0. The better question is, what's the other solution? The other solution is the conjugate. We get to talk about more of that tomorrow. You could check that 2 plus I is also a solution. Number 6, find this quantity in simplest form where I is the imaginary unit. Well, it's x minus I squared times x plus I squared. Now you could do this by brute force and multiply those two out, but watch what I'm going to do here. I'm going to expand those out, write them twice, because I'm multiplying it by themselves. And then I know that the multiplication is commutative of the complex numbers. So I'm going to switch the order and do x minus I times x plus I, because those two are conjugates. I kind of switch these two here, times x minus I times x plus I, because those two are conjugates. And this calculation becomes much, much nicer. Well, x minus I times x plus I is x squared plus ix minus ix minus I squared. That's what that calculation is. Those add to 0, and I get x squared minus I squared is plus 1. Times, well, what's this quantity? This quantity is also, well, that's the same thing. That's x squared plus 1. And now I just need to do x squared plus 1 times x squared plus 1. I'll use a table here for you tabular people. X to the 4th, x squared, and 1. So I have x to the 4th plus 2x squared plus 1. That's the final answer.